Welcome back to our second year organic chemistry part. So we are studying the chemical reactions of alcohol. So to continue with the chemical properties of alcohols. Chemical properties of alcohols. So the next reaction of this alcohol, we are taking the ethyl alcohol as an example. So the next reaction is actually with PCl5, SOCl2 or zinc chloride plus HCl, anhydrous zinc chloride and HCl. So in all these three reactions, we observe that OH group will be replaced by the halogen atom. So for example, if you take this CH3CH2OH, CH3CH2OH, when you treat this with PCl5, it gives rise to CH3CH2Cl along with POCl3 and HCl. It is one chlorine atom with hydrogen, HCl is formed. The remaining three chlorine atoms and phosphorus, it gives rise to POCl3, phosphorus oxychloride, and ethyl chloride is the main product. Similarly with the PCl3, CH3CH2OH, we can take this PCl3 also. Okay, it gives rise to 3 molecules of this one, will give rise to 3 molecules of ethyl chloride, CH3CH2Cl, and we get actually H3PO3. Then coming to with SOCl2, let us say this is A, this is B, the third one is with SOCl2, CH3CH2OH plus SOCl2. SOCl2 is actually thionyl chloride. The thionyl chloride will also react with ethyl alcohol to give rise to the CH3CH2Cl along with the formation of SO2 and HCl. To convert an alcohol into corresponding halogen derivative or chlorine derivative, this is the best method because the other two products are gaseous products. So we will get almost pure ethyl chloride from the ethyl alcohol. The next reaction is with HCl and zinc chloride. CH3CH2OH, ethyl alcohol plus HCl. Here zinc chloride acts as a dehydrating agent. It gives rise to CH3CH2Cl along with the formation of water. So with all these PCl5, PCl3, SOCl2 and zinc chloride and hydrochloric acid, OH group will be replaced by chlorine atom. So the product is ethyl chloride. Ethyl chloride. The next reaction is dehydrogenation reaction. Dehydrogenation. When you take this alcohol vapors, any alcohol for that matter, like primary or secondary, when passed over heated copper catalyst, say CH3CH2OH, when passed over heated copper catalyst, it loses a molecule of water so that it gives rise to CH3CHO plus hydrogen gas. One hydrogen from this carbon atom and one hydrogen from this OH group, they are eliminated as hydrogen to give rise to corresponding aldehyde. A primary alcohol will give rise to an aldehyde. If it is a secondary alcohol, it gives rise to a ketone. Tertiary alcohols do not undergo dehydrogenation reaction. The next reaction is oxidation reaction. Oxidation reaction. The oxidizing agent that we can use is potassium dichromate in presence of concentrated H2SO4 or potassium permanganate in presence of an alkali like sodium hydroxide, or we can also use this concentrated HNO3. Any of these oxidizing agents we can use for the oxidation of alcohols. Ethyl alcohol, CH3CH2OH, on oxidation will give rise to corresponding aldehyde. along with this formation of water by taking this oxygen from the oxidizing agent. So we will get first an aldehyde. The next one is same aldehyde on further oxidation will give rise to corresponding acid. We observe that primary alcohols give rise to aldehydes and with acid and finally acids. This is acetic acid with same number of carbon atoms. But if it is a ketone, if it is a secondary alcohol, it will give rise to a ketone. That I will explain when we consider the distinctions among the primary, secondary and tertiary alcohols. So the next reaction is with oxidation. With any of these oxidizing agents, ethyl alcohol will give rise to acetaldehyde. Acetaldehyde further on oxidation will give rise to acetic acid. The next reaction is iodophone reaction. So the general name for that kind of reaction is halophone reaction. Halophone reaction. When you take this ethyl alcohol, CH3CH2OH, when you treat with this iodine and sodium hydroxide, here iodine will act as an oxidizing agent as well as a substituting agent. First it will oxidize the ethyl alcohol to acetaldehyde. Further acetaldehyde will react with iodine to give rise to triiodoacetaldehyde. Triiodoacetaldehyde will then react with sodium hydroxide to give rise to CHI3, that is iodophone. So overall reaction we can write this as CHI3 plus HCOO plus water plus sodium iodide. So to balance this reaction, you take 3I2 and NaOH. 3I2 and 6 NaOH. It will give rise to CHI3 plus HCOO plus 5 3NaI. NaI plus CHI3, it is 4I2. 4I2 plus 6 NaOH will give rise to HCOO sodium formate plus iodophone. This is actually a yellow precipitate. So this reaction we can use as a conformation reaction for the carbon-carbon oxygen bond. That is all these compounds containing C-CO bond. Whether it is an alcohol or an aldehyde or a ketone, that will give rise to an iodophone reaction. That is if the oxygen atom is at the second position. For example, the compounds which answer for this iodophone reaction as ethyl alcohol, acetaldehyde CH3CHO, CH3CO, that is methyl ketones like acetone or acetophenone, etc. All these compounds will give rise to iodophone reaction. Instead, if you use bleaching powder, chlorine and calcium hydroxide will be present. It will give rise to CHCl3. That reaction we can write as with bleaching powder. With bleaching powder. This is actually fifth reaction in this today's video. With bleaching powder. The bleaching powder is actually a mixture of various compounds. The final formula we can write as CaOCl2. When this bleaching powder and water mixture is used, it will liberate the chlorine gas along with the calcium hydroxide. So we can write the reaction as CH3CH2OH plus Cl2 plus calcium hydroxide, CaOH twice. It will form CHCl3 plus HCOO twice Ca along with the formation of calcium chloride. I think I did not balance water. Number of oxygen atoms is 6 plus 1, 7. Here there are 2, therefore it is 5H2O. Number of hydrogen atoms 5 plus 1, 6 plus 6, 12. 1, 2 plus 10, 12. So here it is the chloroform that is produced. This is one of the methods for the preparation of the chloroform. It is used as a medicine for making the person unconscious. Okay, so that is chloroform. So with bleaching powder, calcium oxychloride, in presence of water, it will give chlorine plus calcium hydroxide, which gives rise to chloroform and HCOO twice Ca, calcium formate. Any such compound, I told you, having this CCO bond will answer this chloroform as well as the iodoform reactions. So this is about some more reactions of this ethyl alcohol as a representative compound. We can generalize these reactions for the other alcohols also. But remember, alcohols are of three types. Primary alcohol, types of alcohols. We have this primary, secondary and tertiary alcohols. Primary alcohols have the general formula RCH2OH. Secondary have got this RCHOH R dash. Tertiary alcohols R3COH. Just observe, there are two hydrogen atoms attached to the carbon atom containing the OH group. It is primary. If only one hydrogen is present, it is called secondary. If no hydrogen is attached to the carbon carrying the OH group, it is called the tertiary alcohols. There are so many reactions we can use to distinguish primary, secondary and tertiary alcohols. So there are so many reactions like Lucas test. Then we have Victor-Meyer's test. Then we have oxidation reactions to distinguish primary, secondary and tertiary alcohols. And also we can use a dehydrating agent, dehydrogenating agent like the copper or silver metal. Heated copper or silver metal. So those reactions we can use to distinguish primary, secondary and tertiary alcohols. That we shall consider in the next video. Thank you.